Hello and welcome to my presentation on fog computing. So first, let's look at what is fog computing. The main idea behind fog computing is to bring computation from the cloud closer to the sources of data. In our case, they are IoT devices, closer to IoT devices and end users, which we will refer to as the things. The diagrams on the left show the positions of the fog computing in cloud to thing continuum. So fog computing introduces fog layer to the cloud to thing continuum. The fog may be anywhere along multiple networks connecting cloud and things. Fog layer computes and stores data generated from things. Then they transmit parts of the data and computation results between themselves or to the cloud for further processing. Fog layers are built from multiple collaborating independent fog nodes. Most of the benefits of fog computing is from the fact that the computation units are closer to the things. So a fog-based system has these following benefits. It has high performance with small latency. It saves a lot of bandwidth used to transmit data to the cloud. And it has cognition, which means it is aware of the customer's demand and could adjust itself accordingly. It's agile, which means it's easy to update, to deploy new application, or to scale the network. The fog networks are geographically diverse, and sometimes they could be mounted on a mobile platform. They use little energy and they open new opportunity for new security features to protect the things. Next, we'll discuss some applications of fog computing. First is the smart transport. So fog computing helps enable intelligent transport system which gathers data from the surrounding environments. Then each of the vehicle or other devices in traffic, they process the gathered data, then they exchange the data with each other. Using the data it has, each vehicle now could make some informed decision to ensure the smoothness and the safety of the journey. In healthcare, fog computing can be used to implement health monitoring systems. Fog-based healthcare applications have the advantage of being energy efficient. They have low response time to emergencies. They are pretty accurate in terms of diagnosis because they rely on real-time data. And they enable development of wearable medical devices. Smart cities collect the data on citizens' activity and infrastructure to empower intelligent decision-making and improve life for their inhabitants. Fog computing enables hardware resource pooling, allow the system to handle the large amount of data, devices and applications required to run a city. Recent studies in fog computing generally focus on the two aspects, either the architecture or the algorithms of the fog computing. Fog computing is a new technology, therefore there are many problems associated with it. First, there's a lot of problems regarding the architecture of fog computing, especially the functionalities of each layer and task division. Next, the fog is used as a shared and distributed computing platform. Therefore, it also faces the same challenge as any distributed platform. Next, securing a fog network is much more complicated compared to a conventional enterprise cloud. And although the performance and energy consumptions are listed as strong points of the fog computing earlier, in fact, there are still room for improvements on these two matters. And we come to the end of our presentation. Thank you.